All right, everybody, welcome back to more Pre-Calc 11. We're going to continue on with our lessons here on solving quadratic equations. Today is kind of a monumental day because today is the day we talk about the very famous quadratic formula. So whenever we have a quadratic equation in standard form set to 0, which is to say ax squared plus bx plus c equals 0, then we can actually solve for x using this formula right here. And take a moment to let that sink in because it's a pretty complicated one. It basically says that x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And so while that is a little bit messy to look at, what I want you to realize is this is kind of a powerful thing because it's going to allow us to take any equation in standard form, and if we're stuck, we could just crank it through this formula and it'll spit out the answer. And normally I would want to dig into the where and how this all works, but I think right now a derivation of this formula might be not the best thing to do, so we might save that for another time. But let's just maybe get familiar with it and start to practice a little bit and see what we can do with it. So imagine we've got this situation. We have to solve 2x squared minus x minus 6 equals 0. So we can solve this anyway, and then we're just going to compare it to solving with the quadratic formula. Let's see what we get. So taking a look at this here, I'm actually going to recognize, I think I'm going to be able to factor this. 2x minus x minus 6 equals 0. I could do completing the square, but I don't want to. And so maybe what I'll do is I'll see what this would factor into. And so don't forget that I have to do 2 times 6. So something times something is going to equal negative 12. And something plus something is going to equal negative 1. And so negative 4 and 3 is going to work for that. So I'm going to split this out. I'm going to just do my little decomposition move. And I'm going to split it into 2x squared and then minus 4x and then plus 3x and then minus 6 equals 0. And then I'm just going to factor these two things and factor those two things. So 2x times x minus 2 plus 3 and then x minus 2, and that's good news. I'm on the right track. And so now I just need to collect again, factor again, and I've got x minus 2 times 2x plus 3 equals 0. And as we saw before, I'm going to set each of these binomials equal to 0 to solve. And so x minus 2 equals 0, that means x equals 2. And over here, 2x plus 3 equals 0. That means x equals negative 3 over 2. And I just kind of skipped a couple algebra steps there, but hopefully you're okay with that. So that's the results we got. 2 and negative 3 over 2 are negative 1.5. So let's compare that to using the quadratic formula and see what we get. So the starting point again was 2x squared minus x minus 6 equals 0. It's really important this whole thing be set equal to 0. But I just want to recognize that we know our a and b and c values. So for example, a in this case is 2. B is equal to negative 1. There is a b value. You just don't see it because we're too lazy to write the 1. And then c is going to equal negative 6. If I take all that and I've got my formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And at this point, I can already feel you asking in your head, do I have to memorize this thing? And the short answer is no, you won't be expected to, although you might become such good friends that you memorize it anyways. So I'm just going to substitute in a and b and c values into this formula, and I'm just going to kind of crank through. Now, because it's kind of a big piece of mathematical machinery, you just have to be really careful with all your plus and minus signs, all your steps. Take your time, work through it, because it's easy to make a mistake. So this is negative times negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 6. Okay, and this whole thing is going to be divided by 2 times 2. So I'm just going to go through, I like to go through and kind of think what's happening with my positive signs. Like for example, this negative and that negative that's going to cancel out and make a positive. So I'm just going to change that right now. When this gets squared, that's also going to become positive. And then this negative sign and this negative sign are going to cancel out. So those are also going to become positives there too. So that's going to maybe simplify things for me. So this becomes 1 plus or minus the square root of 1 squared is 1. 4 times 2 is 8. 8 times 6 is 48. So 1 plus 48 all divided by 2 times 2 is 4. And taking another step, 1 plus or minus the square root of 49 over 4. Well, the square root of 49 is 7, so I guess this is 1 plus or minus 7 over 4. And I want to just pause really quickly here to point something out, which is this whole plus or minus thing might seem kind of weird. We haven't seen that. We've seen a little bit, but maybe you're sort of new to it. Just recognize that all that means now is we've got two things we have to do. The answer is both 1 plus 7 divided by 4 and 1 minus 7 divided by 4. And you know that quadratic equations can have two answers, and this is kind of where the two answers come from. Okay, so if you're wondering how we end up with two answers from one formula, that's it. So my answers, like I said, are going to be both 1 plus 7 over 4 and 1 minus 7 over 4. Well, if we work that out, 1 plus 7 is 8, so 8 over 4, that's just 2. And 1 minus 7, well, that would be negative 6 over 4, which reduces down to negative 3 over 2. And if I look at this answer, and I look at this answer, and I compare them to what I got before, I can see I ended up with the exact same result. So the quadratic formula is not pretty, and it's really easy to make little mistakes with it. But at the end of the day, if we're stuck, if we've got something that doesn't factor nicely, or even completing the square is going to give me fractions I don't want to deal with, you can just take the quadratic formula and just crank the numbers through that. Okay, so that's the best time. That's the best time to use this this formula. Let's do a couple others. And like I said, we're going to see we might get results here that they're not going to be nice, pretty integers, because if they were, we would just factor it, right? So in this case here, I've got a, that's my a value, negative 3, that's my b value, and then negative 7, that's my c value. So x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. Good times. Okay, so b is negative 3. So negative 3 plus or minus the square root of negative 3 squared minus 4 times a, which is 2, times c, which is negative 7, all divided by 2 times 2. Whew. Okay, I'm going to go through and what can I do with my negatives? Well, these are going to turn into positives. That's going to get squared and become a positive. Again, those two negatives are going to cancel out and become positive. So this becomes 3 plus or minus the square root of 3 squared is 9, and then 4 times 2 is 8, and 8 times 7 is 56, so plus 56. All divided by 4. And then taking it one more step further, that would be 3 plus or minus the square root of 9 plus 56 is 67, all divided by 4. Now that looks messy, but I don't think we can simplify that anymore. We can leave it like that, and it's totally fine. If this was some problem, we were actually measuring something or calculating something on real distance or height or something like that, then you'd go ahead and maybe put that into decimals and round off to a reasonable number. But in this case, I'm going to leave it like that. Yeah. So let's do one more here. Let's just split this up. Okay. So this here, again, I need to rearrange this because it's not set equal to 0. So I'm going to bring that 9 to the other side and write this as 3x squared plus 5x minus 9 equals 0. It's really important that this only works if we set the other side equal to 0. So I've got an a value of 3, I've got a b value of 5, and I've got a c value of negative 9. And so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. See, you've got it already. Okay, so this is going to become negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 9 all over 2 times 3. And so that negative sign is going to stay there. There's no negative sign, but this negative sign is going to cancel with that one to make a positive. And so I get negative 5 plus or minus the square root of 25 plus, let's see, 4 times 3 is 12, 9 times 12 is 108, all divided by 6. And so this is going to be negative 5 plus or minus the square root of 133 all over 6. And again, that's not pretty, but I don't think I can reduce that at all. I'm sort of stuck with it. So I do want to point out, this formula, it can be a bit cumbersome, right? It's kind of a big, like I said, a big messy piece of mathematical machinery, but there is one thing about it that's really, really useful. What it can do is I can use it to give me just a quick snapshot of how many solutions I'm expecting for a given problem. And the way I can do that is by looking here at this thing right here. So this part of the equation that is inside of that square root sign, this is something called the discriminant. And it's called the discriminant because it's going to discriminate between, it's going to tell me which of the functions are going to have one solution, two solutions, or zero solutions. So you'll recall that for different equations, they may have any number of solutions from 0, 1, or 2. Okay, and so as a reminder, if we have 2 solutions, for example, okay, so imagine we have 2 solutions. 2 solutions is when it looks something like this, where I cross the x-axis in 2 places. So, and if I get that, that's because my discriminant is greater than 0. So if I get a discriminant, if I calculate a discriminant that's greater than 0, then I'm going to end up with 2 roots. And so an example of that might be this one right here, x squared minus 5x plus 4 equals 0. If I just check the discriminant, which is the b squared minus 4ac, if I just look at that part right there, then remember this is the thing that gets added or subtracted. And so this is going to be the square root of negative 5 squared plus 4 times 1 times 4. So that's going to be negative 5 squared is 25 plus 4 times 4 is 16, and so that is the square root of 41. Now the square root of 41, while it's not a pretty number, maybe, it is a real number. And so I'm going to get 2 answers because I can do my calculation and then I'm going to go plus the square root of 41 and then minus the square root of 41. And so because I get to do that, then this formula, the quadratic formula, is going to spit out 2 real answers. Okay. If I have a situation where my equation returns only 1 real answer, right? A situation where maybe like we come down here and we just barely touch the x-axis in exactly 1 location. That happens whenever the discriminant is equal to 0. So if our discriminant ends up being exactly equal to 0, then we get this result. So like as an example, the square root of b squared minus 4ac, if I have the square root of, in this case b is 4, so 4 squared minus 4 times 3 times 4/3, right? You can see that that's going to be the square root of 16. This 3 will cancel with that 3, and I get 4 times 4. So 16 minus 16 just equals the square root of 0. And so when you go back to that quadratic formula, the number that you would normally say plus or minus this number is 0. And so you can still calculate an answer. That all works, but it's just going to give you exactly 1 answer. There's not going to be 2 different results. Okay, so let's look at one last example here. So we know that there are some times when our quadratic functions don't ever cross the x-axis, right? We get a situation like this. In that case, if we have an equation, that's going to have no roots. That function has no roots, doesn't cross the x-axis, so that equation might not have any real solutions. So this happens whenever the discriminant is less than 0. So essentially, whenever you have a negative number in your discriminant, you can't get a real answer. So if I just rewrite this here, I've got 2x squared minus 8x plus 9 equals 0. If I check my discriminant, square root of b squared minus 4ac. When I plug these values in here, I'm going to get b squared, so I got negative 8 squared minus 4 times 2 times 9. Okay, and negative 8 squared is 64. I'm going to subtract that. 4 times 2 is 8, and 8 times 9 is 72. And so this ends up being the square root of negative 8. And I can't do that. You can't take the square root of a negative number, or I guess more specifically I should say the answer to this is not a real number. And so there is no real number that will allow you to do this. So not a real number. In actual fact, it's something called an imaginary number. And while that's a really interesting topic, it's not something we're going to get into in this course. And so whenever you get the discriminant where that discriminant is negative, you know that your equation has no solutions. You know that the function that describes that equation has no real roots. Okay. I'm going to skip by this example. Might just do it in class instead. I want to get to a word problem like this one right here, because I know that's what you really want to do. So that's what we're going to do. Look at this situation here. We got a framed painting on canvas. It measures 50 by 60 centimeters. And before framing it, she wants to put it on a backing. And the backing is going to have a uniform strip around. So on all sides, you can see this value x here on all sides is showing. The area of the backing is twice the area of the painting. So how wide is this strip of exposed backing showing on all sides, the nearest tenth of a centimeter? Well, normally with these word problems, the first thing I would get you to do is to draw a picture. Lucky for us, they've already done that for us. So we got a really clear picture here of what appears. We've got a really clear picture here of what appears to be a lovely painting. We've got a really clear picture here of what appears to be a lovely painting, and the backing around it. So that part's done. What I am going to point out, though, is we need to find some sort of equation that's going to relate what's going on. And so, for example, I've got a hint here that the area of the backing is twice the area of the painting. So that kind of gives me two hints. One, it tells me that maybe what's going to be important is this area formula, which I know is length times width. So the area of that rectangle is length times width. When we talk about the backing itself, though, the area of the painting, that's easy to find. That's just 50 times 60. But what is the area of the backing? Well, the area of the backing is this width times this length. So when you look at this picture, you can kind of figure out, well, hold on a second. The painting is 50 centimeters across, but then there's an x on this side and there's an x on that side. So the total distance across would be 2x plus 50. And I can reason out the same thing in terms of the length here, that it's 60 centimeters for the painting, but an x on top, x on bottom, so this is 2x plus 60. And so I can take those and put them in my area formula. So the length is 2x plus 60, and the width is 2x plus 50, and that's really good because that expression there you can see is only in terms of x, and if I only have one variable, then maybe I can actually solve it. However, I do need this to equal something, right? I need to have it equal to something so I can solve it. And recall that it's equal to twice the area of the painting. So if it's equal to twice the area of the painting, then the painting itself is 50 times 60, and it's going to be equal to 2 times that, because that's what I was told originally. So this now I can solve, and I'm just going to kind of expand this out and see where it gets me. So 2x squared times 2x gives me 4x squared, and then I've got plus 100x, and then 60 times 2 is plus 120x, and then 60 times 50 is 3,000. And over here on the other side of the equation, I've got 50 times 60 gives me 3,000 times 2 is 6,000. And so while these numbers are a bit bigger than maybe we're used to, this is something we can actually solve. I'm going to bring 6,000 to the other side of the equation. Okay, I'm going to bring 6,000 to the other side of the equation. I'm going to collect some like terms here, and I get 4x squared plus 220x minus 3,000 equals 0. Now, I could go ahead and crank that through the quadratic formula, but I notice here that I can take out a factor of 4. So I'm going to do that. 4x squared, 220 divided by 4 is 55x. 3,000 divided by 4 is 750, and that's going to equal 0. So remember that I can go ahead and just divide this whole thing by 4 and divide this by 4, and then these are going to cancel out and they're going to be gone. Okay, now now that we have it at this point, I'm just going to write this out. X squared plus 55x minus 750 equals 0. At this point, we can go ahead and start to use the quadratic formula. So just note here that A in this case is 1, B is 55, and C is going to be negative 750. So our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We can sub these values in and see what we get. So I'm going to get negative 55 plus or minus the square root of 55 squared minus 4 times 1 times negative 750 all divided by 2 times 1. And so this is going to work out to be negative 55 plus or minus, I don't know about you, but I don't know the square root of 55 off the top of my head, so I'm going to just use this calculator. 55 squared is going to equal 3,025. And then 4 times 1 is just 4. And times negative 750. These negative signs are going to cancel out. So I'll get a positive, and that'll be positive 3,000, all divided by 2. And so my last step is to put it all together. Negative 55 plus or minus the square root of, that would be 6,025, all divided by 2. And so at this point, just recognize that there's two possible answers that this is offering to me. So the two possible answers I've got is either x is going to equal negative 55 plus the square root of 6,025 over 2, or it's going to equal negative 55 minus the square root of 6,025 over 2. And so I'm just going to calculate those here. So let's see, I've got negative 55 plus the square root of 6,025. I'm just going to hit enter, and don't forget to divide by 2. And I get 11.3 centimeters. Now I could calculate the second one right here, but I can actually see, I can tell, without even calculating what it is, it's going to be a negative, right? Because negative 55 minus whatever the square root of 6,025 is going to be a negative number divided by 2. And so because of that, I'm just going to reject it. Remember, I'm finding the width of that band around the painting. It can't have a negative length. That doesn't really make any sense. So my answer must be 11.3 centimeters. And that's my final answer. All right, that is it for the quadratic formula.